Hello and welcome to Lemap TV. Today we're dealing with mathematics, and under the mathematics topic we're dealing with the gradient and the equation of the straight line. Now this is a very important topic when it comes to gradient, differentiation, and also integration. So many other topics that deals with the equation of the straight line. So today we're going to clarify it, discuss the definition and the formula, that is the definition of the gradient, the formula for the gradient. Also we discuss the straight line, the definition of the straight line, the relationship of the straight line with the gradient, the equation of the straight line, and they will solve problems. So all of this we're going to discuss in the course of this video. Now, the gradient in definition is the rate of change of y coordinate, or rate of change of y, let me put y coordinate, rate of change of y coordinate to change of x coordinate. Now, coordinates are actually positions. So positions on the y-axis are called y-coordinates. Positions on the y-axis, positions on the y-axis is called the y-coordinate, or are called the y-coordinates, are called the y-coordinates. The y-coordinate. The same goes for the positions on the x-axis. The positions on the x-axis are called the x-coordinates. The position on the x-axis are called the x-coordinates. I'm sure you'll be familiar with that. So we move straight. Now supposing we have a line or two positions, two straight lines. This is one line representing the y-axis. The y-axis is usually the vertical axis, so this is standing while this is lying. The horizontal axis is the x-axis. The horizontal is the x-axis. So this is the x-axis that has the negative on this side and the positive here, and this is the y-axis, vertical, that has the positive upwards and negative below. Now, the gradient, I said, is the rate of change of y coordinates to change, or with respect to change of x coordinates. Now this is a point on the y-axis. This point, this is a point on both axes that is traceable to the x-axis A and traceable to the y-axis B. Now supposing this point is moved, or this, okay, let's call this point A. Now if there's another point, probably point B, we trace it down, we get C here. I'm giving examples. We trace it here, we get D on the y-axis. If we trace it now, we get a line. That moves us to the next topic, which has to do with the line. Now, a line is the distance, or the shortest distance between 2 points. A line is the shortest distance between 2 points. The shortest distance between 2 points. You're most familiar with that as well. Between 2 points. So we have 2 points there, point A and point B, which were joined together, and that gives us a line. So now line AB is straight, so it's a straight line. Now what is the formula for the gradient? I said it is the change of y coordinates to change in x coordinates, which means it's a ratio of y coordinates. Now there's a change here from B to D. There's a change. It moved from this level to this level. So to identify that change, we subtract. Like, when you go to get something, and then when you finish buying that thing, you also get your balance. So now, like, this is what you went to buy, this is the amount you went with. So that there's a difference. Then that difference is D, which is the new place, minus the initial place. So how do you get it? Gradients are, with this formula, change in y over change in x. So how do you get the change in y? The change in y is final value of y, or final y, minus initial y. This is the final y here, d. This is the initial y here, b. So final y minus initial y over change in x is so the same. Final x, which is c, final x minus initial x. So what is the final x? The final, okay, let's move in accordingly. So d is the final y minus b, which is the initial y, over c, which is the final x, minus a, which is the initial x. Now we represent our gradient with letter m. So m is d minus b over c minus a. We can also represent it like this. Let's call the new point, let's call the final y y2, and call the initial y y1, over, and we'll call the final x x2, minus, okay, the initial, this, we'll call this x1. So this is representing the final points. Now the coordinates of y, okay, this point now we call it a comma b, while this point we call it c comma d, because x values or x coordinates must come first, followed by y. So what does it mean? That the gradient is actually the ratio of the change of y coordinate to change of x coordinate. Now we'll deal with the relationship of the straight line with the gradient. Now I said earlier that the straight line, or a line rather, is a straight line between this shortest distance rather between 2 points a and b, for example. Now if a and b are representing points x1 and y1, and b is representing x2 and y2, you notice that it forms 2 points x1 y1, x2 y2. Now we said the straight line, you want to know the relationship of the straight line with the gradient. We said the straight line is, the shortest distance between 2 points, but the gradient is the ratio of change of the first y points to the x points, which means that if these are the coordinates of the straight line, then we have x2 minus x1 over it is y2 minus y1 as the value of our gradient. Now this moves us to the equation of the straight line. Let's know what the equation of this line is and what it represents. Now the equation of the straight line. The straight line actually is like this or like this. Please note that y is equal to mx plus c is the equation of a straight line, where y and x represents the x and y points for any coordinate on that straight line. Now what do I mean? This is a supposed axis for the x and y, and then this point is representing the origin of that axis. And so if the line begins from this point, it means it began from origin. But there's something else we have not known. I said m is the value of our gradient, y and x represent any coordinate at all. This is x to y, which means that this point is a coordinate on the straight line. And so if you substitute the values of the x and y into that equation, it becomes equal. That is, if you substitute it, multiply by the gradient, add it to this c, which I have not told you about, it gives you the y value. Now this c represents the y-intercept. Now what is an intercept? Intercept is the point where any of the coordinates is equal to 0, which means that y-intercept is the point where x is equal to 0, and x-intercept is the point where y is equal to 0. So while we continue, I want to move to all the formulas that are involved or that we can find in the knowledge of gradient and the straight line. The formulas are as follows. M, already I told you, is equal to y2 minus y1 over x2 minus x1. That's one of the formulas, which means that if you are given two coordinates and you are asked to find the gradient, you use this formula. The second is y is equal to mx plus c. Now, c is representing the point where y is equal to 0. M still represents the gradient. X and y represent an equation. They are like the variables for the equation. And so when you substitute any x to y value, they become equal. That is, the left hand side becomes equal to the right hand side. So these are the formulas mainly that you can find on the knowledge of gradient and the straight line. Also, we can still find one more, which is y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. So this one is another formula. This y and x represent what they have been presented here, the x and y values, and so y2 minus y1, this one represents the gradient that we know, which means you can also say y minus y1 x minus x1 is equal to m. By the time you cross multiply, it becomes y minus y1 is equal to m, multiplying both of them, x minus x1. This also represents another formula for the knowledge of gradient. Now we move to solving of questions. Now we move to the problem solving section of this course. It said find the gradient of the line joining the following pairs of points. It gave us the first point 2, 5, 4, 8, and it gave us second point 7, minus 2, minus 1, 2. Now this method or these questions are actually going to be easy for you if you follow the method and the formula I gave in the initial setting. Now to the solution. Two, 5 represent our first point, that is our point A, because that is where the line started from. Then B is our 4, 8, which represents the point where the line ended. Now to solve it, we move straight to the formula. This is our x1, y1, because this is at the beginning. Then x2, y2. So what does that mean? We substitute because we want to find the gradient. y2 minus y1 over x2 minus x1. So what is our y2? Our y2 is 8. It's going to be 8 minus y1 is 5 over 4 minus 2, which is equal to m. 8 minus 5 is 3 and 4 minus 2 is 2, which means that our gradient m is equal to 3 over 2 or 1.5. So that solves the first question. The second one is also going to be the same way. 7, minus 2 and then minus 1, 2. This is x1, this is y1, this is x2, this is y2. So substitute again. Our m is equal to y2 minus y1 over x2 minus x1. What does it give us? 2 minus, please note that y1 is minus 2. This minus is this one, but y1 is minus 2, so we put a bracket to separate them. This is y1, that is minus 2, over x2 is minus 1. Then we put the minus we have here, the x1 is 7. So what does it give us? Minus times minus actually plus, because the enemy of an enemy is the friend. So that's what we use to find it. So it becomes 2 plus 2 over minus 8. Then this becomes 4 over minus 8, or minus 4 over 8, which finally gives us minus 1 over 2, because 4 will go here to give you 1 and 4 goes here to give you 2. So the gradient is negative, meaning that is minus 0.5. So that solves this one. Now we're going to look for questions on the equation of the straight line. Earlier I mentioned that the gradient is related to the equation of the straight line, and now here is the proof. This next question said find the equation of the straight line passing through the points. Now these are the same points we used in the initial question, and these are what we're going to use in the new question. So this is going to show us how the gradient relates to, or how the gradient is contained in the equation of the straight line. Moving, he said find the equation of the straight line passing through these points. Already we found the gradients for them, but it's asking us to find the equation, and so we use this formula: y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Now because this one is the same thing as m, it means you can say y minus y1 over x minus x1 is equal to m. So this makes it easy for us to solve. We can actually make it easier by multiplying it out, x minus x1. So what we need to do is substitute our x1 and y1 points, and our x1 here for the first question is 2, while our y1 is 5. So this is our x1 here, this is our y1. So all we need to do is substitute. So it's going to be y minus 5 from the equation is equal to, our m for this place is 1.5. So it says 1.5 open bracket. Now 1.5 multiplied by x minus 2, which gives us y minus 5 is equal to 1.5x minus 1.5 times 2 is actually 3. So we can actually make this one much more easier by changing this to the fraction to be y minus 5 is equal to 3x over 2 minus 3. If you multiply all through by 2, you get 2y minus 10 is equal to 3x minus 6. So arranging them properly, it becomes 2y is equal to 3x minus 6, then 10 goes up here, so the numbers go together. It becomes 2y minus 3x is equal to minus 6 plus 10. We have the letters on one side now and numbers on one side. It becomes 2y minus 3x is equal to 4. This gives us the equation of the straight line for the first question. Now to the second question, which is also easy. We are now in the last question, which is 7 and minus 2 minus 1 and 2. Don't forget, we are still trying to find the equation of the straight line, and so we still use our formula y minus y1 is equal to m, this is y, m multiplied by x minus x1. This one should represent our initial points. So this is our x1 here and this is our y1 here. So what do? We just put them into the equation, and our m, which we got for the question, is minus 0.5. So we continue, we write y minus, note that y1 is minus 2, so we put our minus 2 down, is equal to m, which is minus 0.5 multiplied by x minus x1 is 7, so we put 7 there. This is x. We now multiply, open the bracket as well. It becomes y plus 2 is equal to minus 0.5x plus 7 times 0.5. Now 7 times 0.5 actually gives us 7 over 2, which is 3.5. So it becomes y plus 2 is equal to minus 0.5x, okay, plus 3.5. In solving, we rearrange it, so it becomes y plus 0.5x is equal to 3.5. We take 2 to the other side, minus 2. The final equation gives us y plus 0.5 x is equal to 1.5. If you open the bracket, it becomes y plus x over 2 is equal to 3 over 2. If you multiply all through by 2, you get 2y plus x is equal to 3. This actually gives us the final answer for the equation of the straight line of the second question. Trust you had and enjoyed every bit of the video. I taught on definition and formula of the gradient, the straight line, its definition, the relationship with the gradient, the equation of the straight line, and we solve problems on it. Now you could send more of your problems or more of the questions you find difficult in the comments. The next video we'll be discussing on, the next topic rather we'll be discussing on is on differentiation. Having enjoyed every bit, I would encourage you to subscribe to the channel to get more interesting videos. Stay blessed. Goodbye.